In this lesson, we will focus on the knowledge related to lathe fixtures, specifically exploring Task 2.1.1, the functions, classifications, and development history of lathe fixtures. We will understand the important role that lathe fixtures play in machine tool processing, the different types available, and how they have evolved step by step from a historical perspective. By studying these topics, you will gain a comprehensive and in-depth understanding of lathe fixtures. Lathe fixtures are a crucial component of machine tool fixtures, playing an essential role in the lathe machining process. Their core functions are primarily reflected in positioning, clamping, and ensuring machining accuracy. The positioning function refers to the ability of lathe fixtures to accurately determine the position of a workpiece within the lathe coordinate system. For example, when machining shaft parts, fixtures such as 3-jaw or 4-jaw chucks are used to align the axis of the workpiece with the rotational axis of the lathe spindle, ensuring positional accuracy in both the circumferential and axial directions. This is akin to building a house where determining the precise position of each brick is essential to ensure the structural stability of the entire building. The clamping function involves securely fixing the workpiece in the fixture after positioning, preventing displacement or vibration due to external forces such as cutting forces or centrifugal forces during the machining process. For instance, when machining disc-shaped parts, fixtures like faceplates and angle plates are used, along with clamping devices such as bolts and nuts to tightly press the workpiece onto the fixture. This is similar to how we use our hands to firmly hold an object to prevent it from falling or shaking, ensuring the stability of the workpiece during the machining process. Ensuring machining accuracy is a crucial objective of lathe fixtures. Through precise positioning and reliable clamping, fixtures can guarantee the dimensional accuracy, shape accuracy, and the positional accuracy of the workpiece. For example, when turning a cylindrical surface, the fixture can ensure the diameter tolerance and cylindricity for shape accuracy, as well as the coaxiality and perpendicularity with other surfaces for positional accuracy. This is vital for ensuring the quality and the performance of the product. Much like how every component in a precision instrument must have high accuracy to ensure the proper functioning of the entire instrument. Types and characteristics of lathe fixtures. Fixtures mounted on the lathe spindle. During machining, these fixtures rotate along with the machine tool spindle, while the cutting tool performs the feed motion. Fixtures mounted on the lathe saddle. In this setup, the cutting tool is mounted on the lathe spindle to perform rotational motion, while the fixture performs the feed motion. Classification of lathe fixtures can be categorized based on different classification criteria. Common classification methods include categorization by the scope of use, by the source of clamping power, and by structural characteristics. Based on the scope of use, lathe fixtures can be divided into general-purpose fixtures, special-purpose fixtures, and modular fixtures. General-purpose fixtures refer to those with versatility within a certain range, such as 3-jaw chucks, 4-jaw chucks, and centers. These fixtures can be used to clamp workpieces of different sizes and shapes, offering broad applicability. For example, a 3-jaw chuck can automatically center itself, making it suitable for clamping rotational workpieces like circular and regular polygonal shapes. A 4-jaw chuck, on the other hand, allows for the individual adjustment of each of the 4 jaws, enabling it to clamp workpieces of various irregular shapes. Special-purpose fixtures are designed and manufactured specifically for a particular workpiece and a specific operation characterized by their strong specificity and high precision. For example, a special fixture designed for machining a gear shaft of a particular shape can ensure the machining accuracy and production efficiency of the gear shaft. Modular fixtures are assembled from a set of pre-manufactured standard elements and components, offering high flexibility and reusability. In the trial production of new products or small batch production, modular fixtures can be quickly assembled into the required fixtures to meet production needs. Based on structural characteristics, lathe fixtures can be divided into centering fixtures, eccentric fixtures, angle plate fixtures, faceplate fixtures, modular lathe fixtures, and others. Centering fixtures refer to those that can automatically center themselves, such as 3-jaw chucks, spring collets, and liquid plastic centering fixtures. These fixtures ensure that the center of the workpiece coincides with the rotational center of the lathe spindle, thereby guaranteeing the machining accuracy of the workpiece. Eccentric fixtures, these are fixtures used for clamping eccentric workpieces, such as eccentric chucks and eccentric sleeves. By adjusting the amount of eccentricity, workpieces with different eccentric distances can be machined. Angle plate fixtures are composed of angle plates and various positioning and clamping elements. They are suitable for machining workpieces with complex shapes, such as those with holes, slots, and other structures. Faceplate fixtures consist of a faceplate and various positioning and clamping elements. They are suitable for machining large, irregular workpieces, such as engine blocks and gearbox housings. The development history of lathe fixtures. From a historical perspective, the development of lathe fixtures is closely linked to the evolution of the machine tool industry. Since the founding of the People's Republic of China, the country's machine tool industry has progressed from non-existence to existence, from small to large, and from weak to strong. Consequently, lathe fixture technology has also made significant advancements. In 1949, China manufactured its first 6-speed V-belt lathe, marking the beginning of the country's machine tool industry. During this stage, lathe fixtures were primarily manual, with simple structures and single functions, relying mainly on the experience and the skills of workers for operation. For instance, general-purpose fixtures, like the 3-jaw and 4-jaw chucks of that time, required manual rotation of the chuck wrench to clamp and release workpieces. Although these fixtures could meet basic machining needs, they had low production efficiency and limited machining accuracy. With the continuous development of industrial technology, China gradually introduced and absorbed advanced foreign technologies, beginning to improve and innovate lathe fixtures. In the 1960 seconds and 1970 seconds, China started to develop and apply power fixtures such as pneumatic and hydraulic fixtures, which enhanced the clamping force and speed, reduced the labor intensity, and increased the production efficiency. In 1973, China successfully developed its first CNC lathe, marking an important milestone in the development of the country's machine tool industry. The emergence of CNC lathes set higher demands for lathe fixtures, requiring them to have higher precision, faster response speeds, and better automation performance. To adapt to the development of CNC lathes, China began to develop and apply CNC fixtures, such as CNC indexing heads and CNC rotary tables, achieving automated control and precise indexing of fixtures. In recent years, with the continuous development of computer technology, automation technology, and new material technology, lathe fixtures are advancing towards high precision, high efficiency, automation, and intelligence. For example, the use of new sensors and control systems enables real-time monitoring and automatic adjustment of fixtures. The adoption of new materials and manufacturing processes enhances the strength, rigidity, and wear resistance of fixtures. As a leading enterprise in China's machine tool industry, Shenyang Machine Tool has witnessed the evolution of China's lathe fixture technology, from the initial manual fixtures to today's intelligent fixtures. Shenyang Machine Tool has continuously innovated and developed, providing strong support for the transformation and the upgrading of China's manufacturing industry. This also reflects the great journey of Chinese manufacturing, from following to running alongside, inspiring us to keep striving towards the goals of Made in China 2025. Practical application cases of lathe fixtures. In the automotive manufacturing industry, the application of lathe fixtures is very extensive. For example, during the machining process of engine blocks, various lathe fixtures are needed to ensure the machining accuracy and production efficiency of the blocks. By using specialized faceplate angle plate fixtures, the engine block is positioned and clamped on the lathe for the turning of the cylinder bores. Through precise positioning and reliable clamping, the dimensional accuracy and cylindricity of the cylinder bores, as well as the positional accuracy of the bores relative to other surfaces, are ensured. This is crucial for guaranteeing the performance and reliability of the engine. In the aerospace industry, the requirements for machining precision and the quality of parts are extremely high, making the role of lathe fixtures even more prominent. For instance, when machining the blades of an aircraft engine, high-precision centering fixtures and the CNC fixtures are required. Centering fixtures ensure that the center of the blade coincides with the rotational center of the lathe spindle, while CNC fixtures enable precise indexing and angle adjustment of the blades, ensuring the profile accuracy and surface quality of the blades. This is of great significance for enhancing the performance and the efficiency of aircraft engines. In this lesson, we primarily study the functions, classifications, and development history of lathe fixtures. Lathe fixtures have the functions of positioning, clamping, and ensuring machining accuracy. Through precise positioning and reliable clamping, they ensure the stability and the precision of the workpiece during the machining process. In terms of classification, we introduced classifications based on different criteria such as usage range, clamping power source, and structural characteristics, and learned about the features and the applicable scopes of various types of fixtures. Regarding the development history, we reviewed the progression of China's lathe fixtures from manual to intelligent fixtures. The evolution of Shenyang machine tools fixture technology has witnessed the great journey of Chinese manufacturing from following to running alongside. Additionally, through practical application cases in industries such as automotive manufacturing and aerospace, we further understood the important role of lathe fixtures in actual production. I hope that through this lesson, everyone has gained a comprehensive and in-depth understanding of lathe fixtures.